Hello everyone. In this video, we'll be solving problem 238, product of array except self. The problem statement is, we are given an integer array nums. We need to return an array of answer such that the answer of I is equal to the product of all of the elements of nums except nums of I. We need to write the algorithm that runs in O of n runtime complexity without using division operation. I hope you were able to understand the problem statement. The problem statement is very easy to understand and implementation is also easy if you ignore this requirement given to us. Let's switch to whiteboard and discuss the solution. If we ignore the requirement that was given to us of not using a division, the simplest solution would be to calculate an overall product of all of the numbers, which is going to be 24, and run a loop across the input array and divide each number with the maximum product. The result will be saved in the output array, which will be returned at the end. For example, with the total product of 24 and the pointer pointing at 1, the corresponding value in the output should be 24 divided by 1, output is 24. For the next number, 24 divided by 2 will give me 12. After that, it will be 8 and then it will be 6. Considering this approach do not align with the requirements, let's discuss a different approach. Let's try to break this problem down into smaller subproblems. Let's say for number 3, if we want to calculate the product of all of the values except itself, we can also say that we are looking for the product of all of the numbers to its left hand side and multiply that with the product of all of the numbers to its right. Similarly, if we look at number 2, we are trying to calculate the product by all of the numbers to its left, which is 1, and all of the numbers to its right, which is 3 and 4. And we can multiply those two products together to get the output for 2. In other words, we can simply run an iteration from left to right and then right to left, where we'll use a variable to record the running product of all of the numbers as we increment our pointer. Let's understand this better by running a simulation. The left array will record the product of all of the numbers to the left hand side of that particular index. The right will record all of the product of the right hand side elements. Combining the two will give us the output. Starting with the first element, as there are no numbers to its left, the product will be 1. For the next number, that is 2, to get its left hand side, we should multiply the previous LHS calculation with the previous number. That is 1 into 1, the total is 1. For the next number, that is 3, we'll repeat the same cycle. We will multiply the previous number, that is 2, with its LHS product, which is 1. 2 into 1, result is 2. For the last number 4, we'll multiply 3 by 2, the total is 6. Now we have the product of all of the numbers to the left hand side of each index stored in this array. Now we'll focus on calculating the values for the right hand side. The approach is similar, the only difference is this time we are going from right to left. Starting with the last element 4, as there are no elements to its right, the product will be 1 and we'll decrement our pointer to 3. For 3, we'll take the previous number, that is 4, multiply it with its product of RHS, which is 1, the output is 4. And similarly calculate the values for the remaining elements in the array. Now that we have the LHS and the RHS calculated, all we need to do is multiply the values at same index between LHS and RHS to record the output. So for index 1, we'll multiply 1 by 12 to get 12. For index 2, that is value 3, its corresponding values are 2 and 4 in LHS and RHS. The output is going to be 8, and after that the next element is 6. As you can see, we broke the entire problem down into 2 steps and then solved it separately. First to calculate the left hand side product and then to calculate the right hand side and then multiply the output with each other. With this solution, our time complexity is O of n, as we are running multiple iterations to calculate the LHS and RHS, while the space complexity is also O of n, as we are using 2 arrays left and right to record the values of the product. There is one optimization we can do to this solution to avoid consuming additional memory and instead use the output array to record the left and the right hand side product. When we were running the first loop to calculate the product of all of the elements to its left hand side, instead of creating a new array, we can save these values directly into the output array to save some memory. Let's change that first before we discuss the optimization for the RHS. The first run to record the LHS is already complete by moving from left to right. Regarding the RHS, instead of calculating the product and then saving it into the array, why not maintain a variable that will record the product, multiply it with the RHS in the output array and directly save it. It is anyways a running number which will be updated every time we increment or decrement our pointer. We don't need all of the old values, we just need the product of the previous calculation that we did before incrementing the pointer. Let's do a couple of runs to understand this better. Starting with the last element, the right product will be defaulted to 1 as there are no elements to the right hand side of 4. To get the final product, we'll multiply the RHS with the LHS that is saved in the return value variable. That is 1 into 6. The result is still going to be 6. For the next run, we need to include 4 in the RHS product. So we'll multiply 4 with the current RHS, save it, and then decrement our pointer. RHS is 4, the pointer is pointing at 3. To calculate the product, we'll multiply right hand side with the left hand side in the return value. So 4 into 2, the result is 8, which will be saved in the return value variable. For the next cycle, we'll include 3 in it. So the RHS will be 12. We'll repeat the same operation for the remaining elements in the array and update the output array as we proceed. With this optimization, we were able to improve our solution by avoiding to have any additional arrays to store the LHS product or RHS product. With this solution, our time complexity is O of n as we are running 2 iterations to calculate the left hand side and the right hand side product, while the space complexity is O of 1, that is constant space, as we are only using one variable to record the running product of all of the elements in the left and the right direction. I hope you were able to understand the explanation. Let me show you how we can implement this using C#. Here's the C# solution. I start by initializing my return value variable, which will hold all of the products. After that, I'm creating a new variable product, which will hold the running product of all of the values of the left hand side and the right hand side. Next for loop is to calculate the product of all of the numbers towards the left hand side of the current element and save it in the return value variable. After the first for loop is complete, I am resetting the product to 1 and starting a new for loop. This for loop will help me calculate the product of all of the numbers to the right hand side of the current number. And as we calculate the right hand side product, I am multiplying it with the left hand side product saved in the return value variable and overriding the output in the array. And once the for loop is complete, I am returning this return value array as our output. This code, when submitted on LeetCode, beats 100% of the submissions in terms of runtime and 82% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.